So let's take a look at a few examples of bond calculations. Consider this example here. What is the price of a bond that has a coupon payment of $32.50 every 6 months and has 13 years to maturity if the current market rate for this bond is 7.95%? So we're solving for the present value of the bond. That's the price. The face value is $1,000. The future value is $1,000. That's what we're going to receive back at maturity. The time to maturity, the number of periods to maturity, is 13 years times 2 periods per year. So we have a total of 26 periods. The periodic interest rate is going to be 7.95% divided by 2. And the payment is going to be $32.50 per period. Now, a quick note here on the interest rate. For many calculators, you input the interest rate with like this, where 7.95% is entered in as 7.95. In Excel, on the other hand, 7.95% would be 0.0795. So depending on whether you're using a calculator or Excel to do the calculations, make sure you know how to enter the interest rate. One thing you'll notice, hopefully, if you do it wrong, whenever you come up with the result of your calculation, the answer will be nonsensical, and you'll realize that you've done something wrong and maybe go back and fix the interest rate if that's the mess up. So let's look at this example in Excel. If we have $1,000 as our future value, if we have 26 periods, so 13 years times 2 periods per year, 7.95% divided by 2, so our periodic rate is 3.975%, and our payment is $32.50. We're going to solve for the present value, so I'm going to put in here equals PV, and you can see it'll tell you the inputs that it needs to do this calculation. So the first input is the rate, so I'm going to go down and highlight that rate. I'll hit a comma, and the next thing it asks for is in per, so that's the number of periods. So that's in cell B4. The next one is the payment, so I'll go down in here and choose payment. And finally, future value, which is the $1,000 amount. And those are all the inputs that I need to solve for this bond price, and so I get $883.81. I formatted this as a dollar amount. You just want to make sure that you've got sufficient decimal places. 2 would be appropriate for a price, rounded to the nearest penny, but make sure it's showing the appropriate number of decimal places. So a very straightforward calculation. The price is $883.81. Let's consider another example. A bond costs $895.79. The coupon rate on the bond is 4.5%, and the time to maturity is 9.5 years. What is the current interest rate for the bond, or what's the yield to maturity? So our inputs, the present value is negative $895.79. That's how much we'd have to pay to get this bond, so it's a negative cash flow. The future value is, again, $1,000. In the absence of any other information, always assume that the face value, the future value, is $1,000. The number of periods is 9.5 times 2, again, because this is a semi-annual bond. One more time, if it's not stated otherwise, the payments are going to be semi-annual. So unless this said an annual payment, assume that everything is on a semi-annual basis. So the number of periods is 9.5 years times 2. The interest rate is what we're going to solve for, and the payment is given to us. Well, actually, we do have to figure that out. The coupon rate is 4.5%. Because the face value of the bond is $1,000, if we take 4.5% of $1,000, we get $45. Divide that by 2, and that would be our input for the payment. So let's go to Excel and see how we would solve this one. Again, we have all the inputs here. I've put them in this column. $895.79 is the present value, and it's a negative. The future value is 1,000. The number of periods is 19, so it's 9.5 times 2. I'm solving for the interest rate, and then the payments are given here. So I go up here to this part, this cell rather, and I'm going to solve for the rate. That's going to give us the interest rate. And again, I have all the inputs necessary for solving for the rate. So the first input is the number of periods. So I'm going to go and highlight 19. I'm going to hit a comma to move to the next input required, which is the payment, which is right there, the present value, and then the future value. So the interest rate that I get, let me go ahead and get rid of that for a second. The interest rate that I get from Excel is 2.98%. That's okay, it's rounded to the nearest 100th of a percentage point. But this wouldn't be a complete answer, wouldn't be a correct answer, because that is a periodic rate. That's the rate for every 6 months. And so because we use annual interest rates, because we talk about interest rates on an annual basis, I need to multiply that times 2 to get the final answer. And if I format that for a couple of decimal places, it's 5.95%. If I wanted to get a little bit more precise, 5.952% is the yield to maturity for this bond given these characteristics. That's what an investor would earn if they bought this bond for $895.79 and held it to maturity. Let's look at one more example. Here we're going to be solving for a price. If a bond with 20 years to maturity cost $1109.55 a year ago and has coupon payments of $29.50 every 6 months, what is the price today if interest rates have fallen by 0.8% since last year? So this is a little more, maybe a little more complicated. A couple of parts to this problem, but all the inputs are there, all the information required is there. Let's go to Excel again and take a look at this. So we have today a 20-year bond. If a bond with 20 years to maturity, that's where we are today. We got the price a year ago. It's $1109.55. Future value, or the face value, the par value of the bond are all 1,000. Now, when I'm doing my calculation, because the price a year ago was $1109, I need to put in the appropriate number of periods for that point in time. So a year ago there was 21 years to maturity, and so my number of periods would need to be 21 times 2, 42 semi-annual periods. The payment was given to us as $29.50, and so if I solve for the rate, again I'm solving for rate with the number of periods, the payment, the present value, and the future value. I'm doubling that here, and I've got an annual interest rate of 5.05%. Now the question was, what is the price today if interest rates have fallen by 0.8% since last year? So the first thing I had to do was figure out what the interest rate was last year, what the bond was paying, what its yield to maturity was a year ago. Now I need to decrease that by 0.8% per year and then solve for the price. So let me move that over here just to be consistent, where I'm solving for this thing that's not in the same column as all the inputs. The future value is still $1,000. The number of periods now, we're now down to 20 years to maturity, so 20 times 2 is the number of periods. My interest rate, I've decreased it by 0.8% per year. So I took the annual interest rate, subtracted out 0.8%, and divided that by 2 to get a semi-annual rate. The payments are the same, $29.50, and then I'm going to go up here and solve for the present value. So that's equal to the PV with the rate input first, the number of periods, the payment, and the the future value. And the price for the bond today is going to be $1,221.14. And this brings to mind the notion that if interest rates go down, which they did in this case, they went down by 0.8%, that prices of bonds go up, and that's what happened here. The bond price went up by a little over $100 to $1,221. So there's an inverse relationship between bond prices and bond yields. In this case, the yield went down, the price went up. Some more about bond pricing. All of the calculations that we've done so far are to get the flat price of a bond, that is to say, the price net of any accrued interest that might be there. We've in effect been assuming that we're buying or selling bonds immediately after an interest payment, so there's no accrued interest to deal with. In reality, however, bonds are usually sold in between interest payments, and so there's accrued interest that must be paid to the seller of the bond. We have this simple formula here. The invoice price, or the price that you actually pay for a bond, is going to be equal to the flat price. That's what we've been calculating all this time, all these examples, plus any accrued interest that's there for the bond. And accrued interest is a really simple logical calculation. We're just going to take the amount of the periodic coupon payment and multiply it times the proportion of time that has passed in that period. So the days since the last payment divided by the length of the period. So for instance, if we had a bond that paid $25 quarterly, and it's been 35 days since the last payment, then to figure out what the accrued interest would be, we would take that quarterly payment of $25 and multiply it times the proportion of time that has gone since the last payment. And since there are about 91 days in every quarter, the proportion of time, or the portion of time that's passed, is 35 over 91. And if we do that simple calculation there, we get $9.62. That would be the accrued interest that would get added on to the flat price if we were buying a bond at this point in time, 35 days after the last payment. Normally, bonds are sold by the issuer at par. That is to say that the present value, or the price, is equal to the future value of the bond. So they're selling it for $1,000. And this occurs when and if the yield to maturity on the bond is exactly equal to the coupon rate. Now when that's true, then a bond will sell at par. That's usually true, normally true at issuance, but once a bond is sold, interest rates are constantly changing, and at any particular point in time, the interest rate is likely to be different than the coupon rate. So the yield to maturity is likely to be different than the coupon interest rate. Whenever there's a difference between those two, we're going to have a bond that is not priced at $1,000. It'll either be a discount bond or a premium bond. So a discount bond is a bond that sells for a price below par. That's to say the price is less than the face value of the bond. The present value is less than the future value of the bond. And this occurs if the market rate of interest, the yield to maturity, or the required rate of return is above the coupon rate. In this case, the price will be lower than the par value, and you'll have a discount bond. On the other hand, we might have a premium bond. This is a bond that sells for a price that is above the par value. That is to say that the price, or the PV, the present value, is greater than the future value. And this happens if the market rate of interest is below the coupon rate. When that occurs, then we have a bond that is priced greater than $1,000. Now over time, both discount bonds and premium bonds will converge to the par value, with the big assumption that there is no default by the borrower. So if we have a bond that's selling at a discount, it's selling at $800. Over time, that will converge to the face value of $1,000. It may not reach it until very close to maturity, but it's going to be gradually increasing and getting closer and closer to that face value over time. We're going to stop here, and we'll pick up with looking at different bond yields and some bond yield calculations in the next video.
Wondering where you be at, 'cause it's so bad when you're not around. You're never around. It used to be you and me holding hands, smoldering, kicking up leaves, talking about getting older, but now